Hi folks, welcome back to Math with Captain Rod. I'm making this video here to provide more examples of finding the sum of sequences. Alright, so these are the three examples we're going to look at, starting with this guy. I'm just going to take these one at a time. So the sum from n equals 1 to 8 of 3 to the n. I'm just going to start by writing out a couple 3 terms here. So the first term is going to be 3 to the first, which is 3. Plus, right, when n equals 2, this is going to be a 9, plus when n equals 3, this is going to be a 27, plus dot, 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 and then that last term is going to be 3 to the 8th power. Now again, this is a sum of a sequence, which I usually call something like S sub n here. In this case, we're going to be summing out to n equals 8. Now, as I look at this, right, when we get from here to here, that's times 3, times 3, times 3, right? This is a geometric sequence. The a sub n term is given by, let's see, we take our a1 times, let's see, the ratio between these, that's going to be 3 to the n minus 1. Whoops. So another way I could think of this guy right here is 3 plus 9 plus 27 plus dot dot dot, and that last term is going to be 3 times 3 to the n minus 1. And again, this is my S sub n here. Now, there's a trick again for finding the sum of a geometric sequence. Remember that trick. Step 1, multiply both sides by r. In this case, the r is 3. So we're going to have 3 times S sub n equals 9 plus 81 plus, I'm sorry, gotta go back. I was getting ahead of myself. 3 plus 27 plus 81 plus, okay, that last term we're going to have 3 times 3 to the n. Again, when you multiply this by 3 right here, when you multiply 3 to the n minus 1 times 3, you just have 3 to the n. Alright, so that was, remember, step 1. Step 2, take equation 1, subtract equation 2. Alright, so I'm calling this equation 1 and this equation 2. So we're going to have this minus this. And I think I'll just put, how about minus 2 times S sub n for that equals 3 minus, nothing there. 9 minus 9, 0. 27 minus 27, 0. 0, 0. Remember, you get a bunch of 0 pairs. This guy will have one as well. But there's nothing to subtract, there's nothing here to subtract from this, so we're going to end up with just minus 3 times 3 to the n. Right? We're looking for that sum out to n equals 8, so how about we put minus 2 times s sub 8 here is going to equal 3 times minus 3 times 3 to the 8th power. And at this point, I just grab a calculator now. We're going to take this, divide by negative 2, let's see what we get out of those. And I get 39 out of that. Alright, example 1, done. Let's get rid of this. And take a look at this next one. Alright, so the sum from I equals 1 to 4 of 1/4 to the I. Again, you can do this one, you can do these just by brute force. And you know, and I think on this one I'm going to go ahead and just do that. This thing is so short. This is going to be 1/4 plus 1/4 squared plus 1/4 cubed plus 1/4 to the 4th. And I'm just going to go ahead and get a value for that and move on to the next one. Take me a moment here. Oops. It's going to take a little longer than I thought. Sorry about this, folks. Because it would have been faster just to write it out. I get 0.33 3 out of this. Approximately 0.332, good enough for this example. 0.332. All right, take a look at this guy. All right, so looking at the sum, n equals 1 to 5 of 2/5 to the n. And again, I'm going to write out a few terms here. So that's going to be 2/5 plus 4 25ths plus, if I put a 3 here, 2 to the third is 8 over 5 to the third is 125, I believe. 5 squared, 25. Yep. Plus, okay, that last term is 2/5 to the n. All right, so now this is our series here. So we got 2/5 plus 4 over 25 plus 8 over 125 times 2/5 to the n. Whoops, I'm sorry. Out to n minus 1. My apologies. This is starting at n equals 1. All right. Whoops. That does start at n. All right, got to go back. Now that formula was given in the problem. Okay, so that's going to be out to n. Now, this one right here, we're going to play a little bit of a trick here. I want to take this 2/5 and factor 1 out. So rather than calling this the last term, we can put another term there that's 2/5 times 2/5 to the n minus 1. There we go. And there is our last term for a sub n starting at n equals 1. So that very last term is going to look like 2/5 times 2/5 to the n minus 1. Now, the reason I did this is because I want that last term to have the standard geometric form where a sub n is equal to a1 times sum r to the n minus 1. And we want an n minus 1 here, so this is consistent with how we've been working these problems. All right. So there's my series, and there's my last term. Now, we're going to go through the standard procedure here for finding the sum. Multiply both sides by r. In this case, the r is 2/5. So we're going to have 2/5 of s sub n equals. Then multiplying by 2/5. First term is going to now be 4 25ths. Next term is going to be 8 over 125. The very last term here, we're going to have 2/5 times, and when we take this and multiply by 2/5, this term will just be to the n. Right? Step 2, take equation 1, subtract equation 2. So when we take this guy minus this guy, we are going to have minus 3/5 s sub n. Right? When you take 1 something minus 2 somethings, common denominator, right, you're going to end up with minus 3/5 something equals right hand side. This 2/5 gets to stay. Subtraction partner, subtraction partner, subtraction partner. This one will have a subtraction partner. This one will not. There's nothing here to subtract, so that last term is going to be minus 2/5 times 2/5 to the n. We now have a formula here to find our sum. So what I'm going to do is just put in n equals, I'm looking up here, 5. And I'm just going to run a 5 here. That 5 is going to go right there. I'm not going to redraw the new line. Solve that for s sub n. Being kind of cautious here. Okay, and then multiply that by negative 5/3. I got negative 0.660 for this. I'm just going to take a moment here and think that over. Yeah, I think that's probably okay. When I put this in the calculator, I thought maybe there's a chance I did a little bit of goof up here, but I'm going to assume that's right and move on. I hope that this video helps find the sum of a sequence written out in this form. Have a great day.